Cool. So today we're going to talk about, well, actually, why don't I just start with a little introduction? So today we're going to talk about the Gamma Protocol, which is a options trading protocol developed by these nice people here at OPYN. OPYN is OPYN, the team, they provide a variety of strategies for trading ETH options and other cool strategies such as Squeeze. I really recommend checking them out. But this talk is focusing on particularly a product developed by the team, OPYN Finance, called Gamma Protocol. So the link to Gamma Protocol can be found here. You can find it right here, OPYN Finance /Gamma Protocol. The link is also available in the HackMD as well. You can just go ahead and clone that down. For those who are not familiar, you just grab this little SSH link and you should be able to use git clone and just copy that link. And you can make a folder locally if you'd like to follow along. So we can talk a little bit about what Gamma Portal is, but I think before we begin the talk, is everyone just familiar with what options are? Because if you're not, this talk's not going to make sense. Does everyone who here, raise your hand if you're familiar with options?
More or less.
Is it basically saying you're gonna buy a stock or an asset, whatever, at X price, and it expires in 2 weeks or something like that? Is that kind of the gist of it?
Yeah, basically, so an option. The example you gave is a call option, but generally speaking, an option is an agreement between two parties to transact an asset at some point in the future at a pre-agreed upon price. Generally speaking, so the simplest example of an option is a European call or European put, where European call gives you the right to buy at a fixed maturity in the future at a fixed price, right but not obligation is the key word, and then a put option is the inverse, gives you the right to sell. So if you've never seen options before, there's a really nice diagram that kind of looks like this that explains the payoffs of options. So these are European options. Now there's a variety of different types of options. Options are not exclusive to European options, so let me be careful when I say that. But this is your long call, this is your long puts, short call, and short puts, right? So you can visualize S&T as the price axis, and you can visualize the y-axis here as profit. Here, if the price, of course, goes above the strike, the option is said to be in the money. That means it is profitable. Likewise, if for the put option, if the price goes below the strike, the option is said to be in the money. It is profitable. Also, if you're short, obviously you get the opposite of that, right? You short sell something that's making money, you're now losing money. That should be pretty straightforward. So that's basically what options are for. They let you trade these contingent payoffs on some underlying asset. Does that make sense?
Yeah.
Cool. And so now the question.
I wanted to ask, when the person, because there's one person who has to sell the call, and sell the put initially, right? They create it and then you buy it from them. What price do they normally sell it at? The strike? Would the strike price be the current market price, or maybe a premium or a discount of the current spot price? Is what I mean. I don't know.
There's a variation.
What's your question?
Just all over the place.
Yeah.
So if you're selling a stock and it's $50 and you want to get you want to buy a put on it, what would be a fair price? It'd be in 1 month, let's say it expires, right?
Well, I mean, it depends on the parameters of the option, right? So an option can have, so let's be careful here and let's just refine our discussion to European options because there are many different types of options. So when you're working with European options, the two key parameters are going to be the strike and the maturity. The strike is the price for which you're transacting the underlying at. So for example, if you have asset X and the strike price is K for a European call, if you are the holder of that call option, you have the right to buy at K price, right? So for example, if that option is on ETH and it has a $2,000 strike and ETH is trading at $3,000, you can buy ETH at $2,000 by exercising the option. Likewise for a put, let's say for example, ETH is at $1,000 and you have a put option with a $2,000 strike, it gives you the right at maturity to sell ETH at $2,000.
Okay. So like it could be all over the place. Like the strike price that you buy it at could be completely different from the spot price.
The strike price is set. The strike price is set at origination. All the terms of the So to be clear, for European options, the strike price and maturity are set at origination. There's all sorts of like fancy options that allow you to have different types of exercise conditions, different types of strike conditions. There's different types of options that can have different conditions for maturity, and they can get very arbitrarily complex. But refining our conversation to European options, the strike and maturity are known and set at origination.
Okay, cool. Yeah, I was just wondering.
And the time when you exercise the option, is there like a window?
So for European options, exercise can only occur at maturity, right?
And some period of time after maturity?
So it depends on the option market. So
one-day window.
So like in real markets, there's going to be like a window that's set by the exchange. It could be something like 12 to 24 hours where you can exercise it. At that time, that's like the maturity window. But there's no given maturity window. That can be any arbitrary window in theory, right? But we're just saying.
I gotta go, but appreciate it.
Yeah.
Yeah. But in crypto, like in GammaProtocol, is there like a window for exercising?
So in the GammaProtocol, the dispute period is going to be 12 hours, right? So there's a 12-hour dispute period, and once the price is finalized, then if there's a payout in the vault, it becomes eligible for withdrawal. But we'll get to that a bit later.
Okay.
Yeah. Yep. But just generally speaking, like, does this thing that I'm describing here about options, does that make sense?
Yeah, you explained it well.
Cool. Right. So this is how options work. And so now the question is, like, how can we trade options on chain? So you can kind of imagine, like, in a traditional market, like if I just go to Yahoo Finance here for a second, and I just, for example, pull up some quotes on just some arbitrary stock. I don't know, let's put in the Spider ETF for SPY. And I just want to look at the option chain. Right, we can put it in straddle view, and you can kind of get an idea what these markets look like, right? Like you can see here that they're defining this strike in the middle column. You have calls on the left, puts on the right. This is just for the Spider ETF on SPY, and you can kind of see that they're giving you what are the columns here? So the columns here are the last price that it traded at, the change in the price, volume, open interest on the right and the left, which is number of people looking to open contracts. So like if you want to set up an options market, you can think about like you have to have this style of order book for every single pair that you can possibly trade, for every single strike, every single asset, every single maturity. And I think for you're kind of already getting the idea here. If you see how many different maturities there are just on this one stock, right? These things can get very arbitrarily complex. So now imagine we want to apply this to crypto tokens. We want to apply this to ETH. We want to apply this to Bitcoin, right? And you have these style order books. Thing is going to get huge. So on most EVM chains, this type of implementation would just be unfeasible, right? It's just too complex, it's too expensive. Because for every single option here, it's going to have its own unique order book. Right? It's going to have its own depth, right? There's going to be a series of bids and series of asks at different prices. You can think about each option as being its own individual asset with some payoff. So these markets can get really complex. And so like the question is, well, how on earth can we trade options on chain, right? How can we have calls and puts on chain? Like forget about all the really more fancy complex options. Forget about American options. Forget about Asian options. Forget about cliquettes or whatever you want to trade, right? How can we just have basic European calls and puts on chain? And so GammaProtocol attempts to solve that problem using something called an O token. So we can kind of get an idea what's going on here. So like what GammaPortal is GammaPortal is a front end to the GammaProtocol. But what GammaProtocol is it is a standard for trading O tokens OTC. So O tokens are OPYN's solution to trading options on chain, and they provide an implementation via GammaProtocol. So GammaProtocol is providing a way for you to transact O tokens on chain. They built the implementation, right? So GammaPortal is a front end to the protocol that lets you trade these OTC. So like, for example, like if you go to trade here, you can do squeeze, you can do regular OTC, you can make an order, you can take an order, right? So if you make an order and you want to put in some option, maybe I just put in like O3 MAR, let's see what comes up actually, O token. So yeah, for example, you can see all the O tokens that are trading right now. So these are basically OPYN's version of options. So for example, we have wrapped ETH July 23 with a 28th, so this is on 28th, so this actually expires in 3 days. This is a call on ETH with a 2050 strikes, probably worthless. But I can make an order, I can collateralize a vault, and then I can generate an order. I get a string, I can give it to someone else, they can take the order. So that's kind of how OTC trading for DeFi options works. Now, of course, like this type of market structure isn't very intuitive to use for everyday users. So what's happened is a lot of protocols have built applications on top of GammaProtocol, right? So these protocols down here, Ripon Finance, StakeDAO, and Risk Finance, all have implementations that are actually just forks of GammaProtocol. And the exchange I work for, Siren, we are also using an implementation of GammaProtocol. It's a great exchange. I highly recommend you try out our testnet. But so, like for example, if we look at some of the markets, so maybe we can look at, so where are we going to go? So let's think about this, right? So for example, if we look at how this is implemented here, so let's say we want to, I think we have a good front end that kind of shows how this works. Oh, I don't think we have V1 live anymore. Well, I was going to show that for the talk. Let's try RSYK. So let's see, ETH USDC. So yeah, they're actually just providing strategies on top of options. I want to find a good example for you guys. Let's just enter Ribbon and see what they have here for us to look at. So a lot of these exchanges actually aren't letting you trade individual options anymore, which is kind of unfortunate, but we do.
Interfacing directly with the contract, the OPYN.
Correct. So basically what these guys are doing is they're actually generating strategies where what they're literally doing is, like, for example, if you want to go into Ribbon and deposit into a vault that earns money, like they say you can earn 41.18%. Like depositing our ETH, staked ETH, right? What they're effectively doing is they're generating vaults and they're selling options against that collateral. And they're basically making these markets via GammaPortal or the GammaProtocol, right? So people are taking the other sides of those trades. So that's kind of how that all links up. That's actually where those APYs are coming from. And basically Ribbon's doing that, Risk is doing that. They hedge it using a dynamic hedging vault, which is an interesting implementation. And StakeDAO is doing a version of that, but it's basically all the same idea under the hood, actually. So begs the question, like, how are all they doing this, right? How is it that you can provide our staked ETH and earn 41.8% by selling these options? Like, how does all this work? Well, this is linked to GammaProtocol. So with that, I think it'd be a good idea to try and introduce what O tokens are. But I guess before that, is there like any questions, like what's kind of going on here?
No. I think it all depends on the O tokens, really.
Right. Yeah, you can see down here, like they have put selling, covered call. You can earn these yields.
I have a question. For
Yeah.
non-covered trades, how do they enforce it? What's stopping me as a user from doing a bunch of naked options and then if it doesn't work out, walking away?
There's no naked options via OPYN. Using the standard implementation of GammaProtocol, that's actually not allowed. The transaction would revert. Right. So there is a sufficient collateral. The collateral, though, in the vaults is a function of the parameters, right? And so it is possible that a vault could become under collateralized under certain market conditions, because in theory, the options are partially collateralized relative to the maximum possible loss on those options. But because we know the option payoffs are contingent, it's not actually necessary to fully collateralize them at onset. So for the most part, all these strategies are actually relatively safe.
Yeah. So to touch on that, so if I sell a call on ETH for like 2050, right, and then the price I would have to put collateral down to like finance that in case like that was in the money and that actually had to happen. Like, but there must be like an upper bound at which like my loss must be bounded by the collateral, right, that I put in. Like if the price of ETH went to like a $5,000, you know,
well,
by the time of maturity.
If you wrote a call, your losses on an O token on the vault is going to be limited to the collateral that was used to collateralize the vault. So if you are the sole, if you are the owner of that vault, right, then if you're the count owner on that vault to be specific, then your losses would be restricted to the collateral that you deposited on that vault, which would be a fraction of the maximum possible loss on the option. However, if you wanted to keep the position open, you would have to continue to deposit collateral, otherwise the vault could be subject to liquidation.
Would they close it early?
So similar to, do you know how like on Aave when a loan becomes under collateralized, liquidators can come along and take away your collateral at a discount?
Yeah.
Same idea.
Okay.
Same exact idea. So there's actually a lot of MEV opportunities by looking for vaults that are about to become under collateralized.
Gotcha.
Yeah, so if you're interested in MEV, that's a whole other conversation. Cool. So, yeah. So I encourage you guys to, of course, look at Siren. We're awesome. Try our testnet, but also, check out some other protocols as well. Get a feel for what DeFi options look like. There's a lot of cool projects out there. With that, why don't we just go ahead and look at what an O token is. So this is the Gamma portal. I'll keep saying portal. This is the Gamma protocol. So Gamma protocol, this is the master branch that I pulled down from the official OPYN finance GitHub. So encourage y'all to pull that down and you can look at it locally. Gamma protocol is quite complex. There's a lot of moving parts here. It has a lot of different contracts that have to be deployed, a lot of different external calls being made. If Colin was here, he'd probably have an aneurysm looking at it. But it's it's a very good piece of tech. But at the core of what it is basically this O token contract, which is actually just an inheritance from ERC20 tokens, right? So let's not worry too much about building from the ground up here, and let's just think about what an O token is, right? So fundamentally, remember what we were talking about. An O token is just representing an option. So you can literally think of this O token as being this option, right? So O token could be a call or it could be a put, European specifically. And so questions you might ask are, what do we need to know about a call and a put? So let's just ignore the controller for now. This is a very important component of the protocol, but we'll discuss this a little bit later, what the controller is actually doing. But the properties of an option are going to be, what is the underlying asset? What am I underwriting a call or put to? What is a strike asset? Am I paying in this? What asset am I paying or selling in, right? What is the collateral asset, right? So all O tokens have to be collateralized. What's collateralizing the option? What's the strike price? This one's pretty straightforward. What price are we transacting at maturity? Speaking of maturity, what's the expiry timestamp, right? So when does the option mature? Is the option a call or a put, right? Now these are some technical details. So, WETH uses 8 decimals. So the strike price scale is 1E8, and they use 8 digits here. This is actually hard-coded, so this is made for WETH or wrap tokens, which have 8 decimals. And here we have the initializer. So if you've ever written code before, an initializer is the same idea as a constructor. It builds the object, right? So Well, all we're doing is we're just setting those variables. So you set your address book, you set your underlying asset, you set your strike asset, you set your collateral, etc., etc., etc.
For those assets, like for the underlying asset, for example, it's an address. Is that referencing another contract?
I'm sorry, can you ask your question again?
If you look at like the underlying asset variable,
Mm-hmm.
its type is an address.
Correct.
Why is it an address and not or
So-
what is the address pointing to?
The underlying, so all Ethereum smart contracts have what's called an associated address once they're deployed. So what it's actually pointing to is the associated address of the token, ERC20 token, that references the underlying asset for the option. So here, for example, the underlying asset could be WETH. So if this is an O token on WETH, that would be the associated address of the wrapped Ethereum deployed contract.
Okay, so for the GammaProtocol, every asset that can be traded has its own contract deployed.
So can you ask that last part one more time?
I think it's a little different. First, you know what ERC20 is?
Yeah.
So to have an ERC20 token, there's a contract that's deployed and an address for that token. That's what
Oh,
this
I
is.
understand. It can be arbitrary. It could be any ERC20 token. Right, okay, I see.
Mm-hmm. Yeah.
So you're just putting the address of that ERC20 token.
I get it.
Mm-hmm. Yeah, so these are addresses to the contract that deploys the ERC20 token, to be specific.
I was thinking like Gamma was deploying separate contracts for every asset that they supported.
No.
But no, that makes sense.
No, GammaProtocol does deploy a lot of contracts, though. But yeah, so these are the assets of the ERC20s. Strike price, self-explanatory. So we use a UINT 256 here because we're basically representing floating point math using integers. So the ways you do that, so Solidity, something to keep in mind is you don't have floating points natively in the language. So you simulate floating point numbers using integers, and then you just, convert it when you need to. So it's understood. So what we say when there's 8 decimals is we say that we're computing a number to 8 decimals of precision, right? So you can think of like dot 1, 2, 3, 4, 5, 6, 7, 8, right? But we're representing that using an integer. So that's what that is. And that just basically initializes the contract. And so we can see what methods are defined on there. We have get details, describe it to me. What is it, right? So it's just returning information about the O token. We have a function that can mint O token. We have functions that can burn O tokens. We have functions that can get information about the name and symbol. We have functions that can tell you what the strike price is. And we have some helper functions around converting integers to characters and getting the option type, etc. So that's just what the implementation is. There's a lot of little technical small stuff here, like external. Do we all know what these keywords are? Does anyone want me to explain that, or do we not care about that?
I don't know. Does anyone want the internal, external explain?
No.
So no one knows what internal, external is?
No, I know what it is.
I know it.
Internal means it can be called from within the contract, and external means it can be called from outside via like the API, via the
Right.
node.
So in Solidity, yeah. So for those who don't know, in Solidity, there's this idea that some variables, some functions should not be called outside the contract, and some can be. You can think of this as public and private in other languages. That's the right way to think about it. But yeah, this is the O token. So O token is again just an inheritance on top of an upgradable ERC20 token. I think we all understand ERC20s here, but does anyone want to look at what that is, or do we just want to move forward?
Well, so it's when you're requesting a new O token, you're not calling a NIT, or are you calling a NIT? like when you want to create a new O token, is the client calling init?
So when we derive the class, right? So this is an inheriting contract because it inherits from another contract. But when you're constructing this contract here, right, you can see that I'm not making a call to the parent constructor. Instead, what I'm doing here is I'm defining what the initializer is. I'm inheriting from the ERC20 interface because I want those methods that are defined there as well. So that's the point of inheritance, that you get all those methods that are defined above. For example, you can see here we have methods for minting and we have methods for burning. Those are actually defined inside of the ERC20 contract.
So which function would I call as a client to create a new O token?
You don't. You're actually going to interact with the controller.
Okay, I see.
Right. So, like, for example, I mean, you could technically, I mean, if you look at this, the initializer,
It's external.
yeah, it's external. External has this modifier called initializer on it, which, where is that modifier actually coming from?
Maybe it's coming from the interface.
External initializer, modifier, argument initializer. Modifier to use initializer function of the contract. That is a great doc string, whoever wrote this. Phenomenal work. Actually, not sure. But you should be able to actually just, in theory, create an O token, but like it's not going to be part of an official vault or anything, so it doesn't matter.
Okay.
Right.
Because by itself it's useless.
Yeah, by itself it's useless. You can create whatever useless contracts you want on chain. No one's going to stop you. But cool. So now, what do we do with O tokens? Like, how do these actually fit into like the whole protocol? Well, so like if we go back to Chrome here for a second, like all these protocols, including ours, are built on the idea of having these vaults that are actually holding the O tokens here. So, for example, when they're creating this strategy here, where they're creating this put selling strategy or covered call, they're creating these vaults that hold the O tokens, right? That's what they're basically creating. So the vaults, O tokens are held inside of vaults. So that's the next key component of the Gamma protocol. So we can so when you're depositing money to, for example, Ribbon Finance for one of these strategies, what you're actually depositing to is to that vault, right? Now what are vaults? Well, we can take a look. So vaults are going to be under margin pool, external interfaces. I think it's under libs. Yeah, margin vault. Here we go. So we can kind of take a look at the margin vault. So a vault has a structure, right? This is a library. Library you can import from it. It has stuff that's defined in there that's useful for you, similar to other programming languages. So note here we're using safe math, by the way. Do we all know why we use safe math?
No.
So safe math makes sure you don't have overflow or underflow errors, right? So on its own, Solidity was not safe against, basically you take two big numbers, multiply them together, results in another big number that could be bigger than the number that you can represent. And what happens is it actually wraps around to the other side and you get a negative number. But use safe math, it prevents that from happening.
I think it's because this is Solidity 0.6, right?
I believe so, yeah.
I think as of Solidity 0.8, you don't need to declare safe math anymore. I think it's actually the default now.
Under 0.8?
I need to double check. I'm pretty sure that it was in the newer Solidity. They had changed it, but
for a long time you had to do it this way because I think there's back in the day there were some protocols that didn't understand overflow and underflow and that led to issues. But this is the structure of a vault, right? So you got O tokens here, short, long, collateral assets, short amounts, long amounts, collateral amounts. Basically what you would expect. So this is the implementation specified by OPYN. You have an array of short O tokens. These are basically options that the vault is short, so you're short a call, you're short a put. You have short long O tokens, you have long O tokens, so these are options that the protocol is long. So for example, long call, long put. Collateral assets, what assets back the vault's value, right? So typically that's just going to be USDC. Short amounts, so for those short O tokens, what quantities am I short? 1, 2, 3, 4, right? Long amounts, same idea, and collateral amounts, like how much collateral do I have for the collateral assets?
For the collateral assets, you said typically it's going to be USDC and not the underlying assets created in the with the O token.
Well, it doesn't necessarily have to be strictly USDC. Like there's no requirement here that use USDC, but most of the implementations that exist today are using USDC as collateral.
They'll convert it?
No. So what's happening is that, for example, let's say you have a option that is a payoff based on wrapped ETH, right? So for example, the strike price might be wrapped ETH, the collateral might be wrapped ETH, but then the underlying might be, the strike price might be USDC, the collateral might be USDC, but then the underlying might be wrapped ETH. What's actually happening there is that basically the payoff becomes a contract for difference on maturity, and it's actually based on the price oracle in that instance. But of course, you could have collateral that is volatile, like wrapped ETH, but that presents issues on its own.
So most people are actually not dealing with wrapped ETH or something like that. They're dealing with USDC when they're buying these options. Regardless of what
typically they're dealing with USDC, right? So actually the real risk here is in Circle.
Okay.
But yeah, that's just basically how it works. That's a vault. You have short options, you can have long options, you can have collateral. That's it. It's actually very simple. That's all a vault is. So all these strategies, all these protocols, that's all it is.
There's no. Oh, where does the O token fall in with the vault? Because I don't see any O token type.
So we have to create vaults, we have to collateralize vaults, and we have to do stuff with vaults, right? And all of that stuff is handled by all this stuff over here. So it's actually creating the vaults, making sure they're properly collateralized, managing the vaults. That's actually quite a complex process. But the actual vault itself is really markedly simple, right? That's all it is.
On the UI that you were looking at, was it Siren UI on the other in your browser?
Our protocol is called Siren, yes.
And you had a list of all the or what you could trade, the options that were available. And I think it was in a different tab. In the tab you were on before.
What are you referring to?
Oh, you mean Ribbon?
Oh, maybe it was Ribbon. Yeah. Yes, here. Is each one of those a vault?
Yeah.
Yes.
Yep. It's actually just this. So, I mean, the idea behind selling options is that if the option that you sell expires out of the money and someone bought it from you, then you keep the premium, right? So that's how you actually make money, by selling options. So options are said to be an income strategy for that reason. So that's how they're able to offer APY on these strategies. They're actually just selling options. You can do the same thing. You actually don't need to use any of these protocols. You can trade OTC. That's all it is. Yep, so I hope that demystifies it. But yeah, on a vault, there's a variety of functions that are in this library that are defined here to help us work with vaults. So for example, let's say we want to add a short option. So you can see that adding a short option is actually not as simple as it seems, right? We have a vault. We have an address to a short O token. That's an O token that we created in the previous step, right? Let me do something here so I can look at these side by side. And then we can close. Let's open this guy side by side. Right, so we can look at these side by side now, right? So for example, if we are adding a short here, right, O token. It's an address to the short O token. So it's the O token created from initializing this contract over here, right? That's what that is. We have an amount. How many of these short O tokens is it holding? So this is the specification to the short O token. And we have a index, which refers to a position that you want to put it in this array in the vault, right? So short O tokens go here in the short O tokens array. Let's look at how a short O token is added to the vault, right? So we have all these conditions we have to check. Like it's just kind of a technical operation here, but it's just some basic if-else logic, right? Right, obviously we have to add something that's non-zero to the vault. That's an error, that's your V1 error. The index has to be at the end of the array, so we're not overwriting any tokens here, otherwise you have to come down here, right, and we have this other condition here, where we can basically update or add to an existing short. So we're either adding a new token or updating an existing short position. And that's basically all this if-else logic does.
Updating would be replacing one O token with another.
Well, you can see here it's actually adding the amount. So you're now extra short. So maybe I'm short 2 of the same option now, right? Because remember, O tokens, like the ETH, like if I go back to GammaProtocol for a second, right, and I look at this option that we could sell, maybe I want to make an order on 28 July 23, right? So 32,500 call on wrapped Bitcoin. So that's ambitious. Let's say I've already short some of these and I want to sell more. Well, I'm going to get an address for the O token and then I can just add more to the vault, right?
Are we going to look at the algorithm that underlies like the maker fee and the fee to buy the option or sell the option?
So the price to buy or sell the options is set by the market maker. That is at the market maker's discretion. So market making is a whole can of worms. It is a very complex subject, and that's what I think about every single day. Generally speaking, you want to mark to an existing liquid options market wherever it exists. If a liquid options market does not exist, then every firm has their own secret sauce for how they come up with a price. I certainly have mine.
Is that typically variable or set?
Well, I mean, it's whatever the market will bear, right? So, I mean, in theory, the fair price for anything is what someone will pay you for it, right? And so if you're making a market, for example, where there exists no other liquid option market,
Sure.
and I'm setting the price, if you're paying the price, then my price is the right price.
Sure.
Right? If I raise my price and you still pay it, my price is still the right price.
Okay. But it can vary depending on market conditions and what your competition is doing.
Oh, yeah. Right. So option prices, generally speaking, reflect the market maker's view of, well, they reflect a variety of things. They reflect the cost to hedge. They reflect the expected hedging errors. So how difficult is it to hedge? They reflect financing costs, and they reflect inventory in the market maker's book, generally speaking. Every market maker has their own formula and secret sauce. There's a lot of different academic papers out there on market making, but there isn't, generally speaking, one specific right way to do it. There's a lot of different models for coming up with prices, and they all have different advantages and disadvantages depending on the type of market that you're trading. And yeah, and that's what market makers think about all day, which is how do you make better, more efficient prices. Making markets on options is a very, very difficult science. But it's also a little bit of an art as well, because you can have all the fancy mathematics in the world.
It's also a function of demand.
It's a function of demand, right? Having the most sophisticated hedging model out there isn't necessarily going to help me if no one's going to take my order. All right, so this is for adding shorts, removing shorts, same idea. So I could go into these in detail, but I don't think I need to bore you with the semantics of how you add and remove from an array, unless anyone wants me to actually cover that.
No.
Right? I think that makes enough sense. You can add collateral, you can add or remove stuff. This is a vault. Vaults hold options. I hope we understand that. Cool. So, moving on from that, how are vaults created? So, why don't we take a look at the controller? Because the controller, as the name implies, is controlling everything. It's because it's the controller. Right? So we'll close this. Let's take a look at the controller. So the controller is, as the name implies, controlling everything. Controller is a huge file in here. I encourage you all to look at it on your own time. It's just huge. But the general idea of the controller is that it's going to run a series of actions. So there's this key function here called run actions, and that's really what you can key on. Right? Because this is what's actually doing everything. So generally speaking, when you want to create vaults, when you want to add options, when you want to settle vaults, when you want to do any of the various actions that you could run on the protocol, you're actually going to end up calling the run actions function inside of the controller, right? Which is actually called by the operate method. So specifically, you go operate run actions, right? But let's just focus on run actions right now. So what run actions is actually doing is it's taking a list of actions that you want to run and it's operating them. That's it. So for example, some of the actions, you could settle a vault, which occurs at maturity after the dispute period is finished. You could redeem collateral if there's excess collateral in the vault. Maybe the vault's over collateralized, right? You can liquidate a vault if it's under collateralized. So this is actually a great way to generate MEV. This is action type dot call. Actually, that's a new action that's been added by. Okay, I'm not familiar with that particular action. And yeah, and so basically when you run the actions, you can open a vault, you can deposit a long option, you can withdraw the long options, you can deposit collateral, you can withdraw collateral, you can mint a short option, you can burn a short option, you can redeem collateral, you can settle the vault, you can liquidate, and you can call, right? Which means to call the collateral. So these are a series of options, and all these functions have their own implementations that actually run it. But that's the fundamentals of what you can do with the controller. So you can kind of think of the controller contract here as having this big contract that defines all these methods that actually do the work of managing the vaults, creating the options, adding collateral, removing collateral, running liquidations. So what you're actually working with when you use GammaProtocol is the controller, and then you have all these other contracts which are being operated on by the controller.
And the controller also creates the vaults, right?
So yeah, so for example, if I want to open a vault, you can see literally here. You can see literally here it's an action. So if I just look up the open vault method, we can see what it does. Yeah, there it is right there, right? So you can open the vault, take some arguments for how you can open the vault. And what it's doing here is it's just basically incrementing the vault counter. And then it is going to open a new vault. All right, so it's actually just adding a new vault to the index. So you have this basically array of vaults that the controller is storing a reference to. And each vault has its own owner, which is the person who opened the vault. And each owner can have potentially multiple vaults, which is why you have a vault ID. So it's an array of arrays, or mapping, if you will.
So these different sites that are interacting with the protocol, with the GammaProtocol, their vaults are not, even though the options may be the same underlying asset and the
same controller, yeah.
Oh no, but it's the same controller. But even though if they create a vault, even though all the parameters may be identical to RYSK, it's a different vault.
Well, if you're using the standard implementation of GammaProtocol, the margin calculations are going to come from the margin calculator on GammaProtocol. Some protocols have their own implementation.
No, but I mean, it's based on owner. It's based on the.
Well, the vault is, so this is a mapping to an array, right? So the array of vaults is owned by the address, right? So it's going to be address. So we can just look at it here, yeah? So vault type. We can just, seriously, we can just look at where it's defined. Vault type equals, where's that defined? Oh, vault type, I think this
If you
is,
hover over it, will it tell you the type?
should define declaration 107 undefined state var controller vault type declaration 107. Here we go. So it should be here. Yeah. So it's a mapping. So a mapping in Solidity is similar to a dictionary or hash map, if you will, where you're basically mapping this string or hashable value to some sort of array structure. And here, basically, the vault type is a mapping to a mapping to a uint256 variable. So effectively here you can think of it as like a nested dictionary for those who write Python code, where basically that's just going to be a string
Well, what I
mapping
mean
to
is
the
that-
vault, mapping to the vault.
What I mean is that those other sites like RYSK and SI.
Well, vaults is here, by the way. And yeah, they're here.
They're not sharing vaults between them.
So you can trade O tokens, right? You can trade them, right? You can reassign who owns, you can trade it, right? These are tradable, right? These are assets, right? You can change who the owner is, because O tokens, remember, are an derivation of the ERC20 interface. So O tokens are tradable, right? So, for example, every position, if I have a vault that holds O tokens, the vault holds collateral, right? That position's represented by the vault, and then these can be transferred. So you can trade these, basically, you can trade these vaults, right? But the owner is going to be the protocol. So, for example, if it's Ribbon Finance, they are the owner of that vault. You are depositing to their vaults, where then they are now selling options. So, for example, if I'm them, what I can do is I can have one that's going long and it's buying a lotto tickets. I can have one that's going short, and I can just take a fee and just have you guys trade against each other, right? So that's just kind of how that works.
That was my question.
Yep. That's what that is. But yeah, controller is a really complicated contract. I don't think I could go over it in an hour if I tried. All you need to know about the controller is it controls everything for the protocol. So you can kind of think of the structure of GammaProtocol as this big contract called controller that creates these vaults that hold options. And these options represent the various types of strategies and positions that you can be composed of European calls and European puts of various strikes and maturities. That's the best way to describe it. A lot of other things here. So, for example, like one of the things I mentioned earlier is like, how do we know, like I think you asked it earlier, where it was like, well, how do we know there's enough money in the vault for the payoff, right? Well, that's determined by the collateral in the vault, right? So when you create a vault, you have to verify that there's sufficient collateral. So if we look at the operate function here on the vault, you can see that it runs all the actions, and then before the transaction finishes, it calls this function called verify final state. What verify final state does is it verifies that you have a valid vault, which means no under collateralization. So if I look at verify final state, you can literally see what it's doing is it's calling this get excess collateral function, and is valid vault. This is actually just checking, is there excess collateral? Because if I go to the margin calculator and look at this function, it's just checking, is the collateral bigger than the requirement for the vault? If it is, then it's valid. Right? So this is no different than collateralized loans on Aave, for example. That's
there a specific, is it just an arbitrary requirement? Like threshold of collateral?
well, GammaProtocol provides their own implementation. OPYN provides their own implementation what those parameters should be. But other protocols can, of course, they can create their own margin calculator. So, for example, if you look at the calculator here, right, you can use the official calculator, which, is used by GammaProtocol. Of course, there's nothing to stop you from creating your own. They just would not be part of the official GammaProtocol because, there's an associated address with that controller. Yep. So vaults created from an associated address to a different controller would obviously not be GammaProtocol. It would be a fork of GammaProtocol. Right, so but the calculator is what's actually determining the margin, and the margin calculator, generally speaking, like how the margin calculator works if we look at get required margin, there's a lot of different parts here. Oh, so where is get required margin? Get excess collateral. Let's look at that. What is this guy doing here? So it's greater than equal collateral. So there's this function in the vault. So let's look at this. So get excess collateral, which is the function called by the controller that checks if the vault is valid when it's created. The thing that it's going to be returning right here is excess, right? So what is excess is actually doing is excess, it's a Boolean variable. If you can see it's declared right here, if the excess collateral is greater than or equal to 0, it's true, else false. Excess collateral is the difference between the amount of collateral in the vault and the collateral required. Makes sense. Collateral required is literally just this thing returned by get margin required. That's the amount of margin required to originate the position in the vault. Notice that this function takes an argument called vault. Right? So what this is actually doing is it's fetching the details from the vault details from get vault details, and then from these details it passes it in to get margin required, which then computes the margin required, right? So if we look at get margin required, right, you have a vault here, vault details, and this function here will actually go ahead and compute it. So what this is actually effectively doing is there's a lot of different pieces going on here. And I can let you read it in your own time, but what's effectively happening here is that so GammaProtocol thinks about it in the following way, right? So what is the risk to a short option seller? The risk is the price goes against you, right? So if I write an option and I'm short, let's say I write a call, and the price goes up, that's bad for me because now I owe someone money if they exercise the option.
Because you're short.
Right, because I'm short. So you can think about it is the margin requirement as, well, how much could the price go against me? And if the price goes against me by that amount, is the collateral in the vault sufficient to cover that potential liability? And so that's basically what the margin calculator is focused on. So you can think about it as a high level, that the required margin is going to be that shocked intrinsic value plus the potential extrinsic value on remaining options in the vault, right? Because the vault has to be properly collateralized at all times. So extrinsic value goes to 0 as the option goes infinitely in the money, and intrinsic value goes to the underlying, right? That's the asymptotic condition. But what the get margin required function is doing is it's actually going to be computing shocked intrinsic, adding shocked extrinsic, and then getting a margin requirement. There's a lot of offsets that can be figured out based on the strikes, but that's kind of a little bit outside the details of what's going on here.
But then doesn't it need to happen like a periodic time frame, independent of whether or not people are interacting with a vault? Because it could become under collateralized.
Yeah, so GammaProtocol isn't evaluating it. So let's think about what the MEV opportunity is here, right? How can I make money? Well, there's two ways. One, I could take price risk by writing vaults, or two, the other way that I can make money is by getting the address for every single vault and then watching when they become under collateralized. If a vault becomes under collateralized, then there is this function on the controller. This is the fun part. There's this function on the controller. This is where you can make money. Is liquidatable. It's on the calculator, excuse me. So is liquidatable. What is the is liquidatable function going to do? How can we make money without taking risk here? How can we get MEV? What is MEV? Let's look at what is liquidatable is doing, right? So it takes the vault, all the information, and what's it doing? It's checking the vault details, checking that the price isn't finalized, all that good stuff, getting the market margin required, and if the vault has excess collateral, then obviously it isn't liquidatable, it returns false. But if the vault is under collateralized, it returns true, and it returns true, it gives you this debt price, which is just basically the ratio of the amount owed versus the amount of collateral in the vault, and the amount of dust, or the tolerance allowed for liquidation.
Is
So-
it a pure function?
This function is liquidatable, is external.
I mean, view.
View, yep. It's view. It's a view function. So how can we make money with MEV here, right?
You can go through all the vaults and call this function.
Yeah.
on
So
every single one.
That's exactly it. I can go through the vaults. I can keep track, figure out when they're under collateralized. When they're under collateralized, what do? You can use flash builders. I can take a flash loan. I can buy the collateral from the vault, then send it to Uniswap, sell it, and then I can return the loan back to Aave and then basically make a profit, right? So you can do it all within one block with no collateral. So the MEV opportunity here is to use flash loans to liquidate vaults. And these vaults typically allow for some amount of profit, right? So you notice here this little dust component. So it's a little bit more.
What is the dust?
So dust here is a tolerance.
Okay. There's some tolerance where it won't let you liquidate if it's like.
Because if it's within a certain amount,
1E8.
Exactly. It's just something. But basically, they had defined this function here called debt price. So debt price says, what is the price for liquidating that collateral? So if we look at where debt price is required, so get debt price, we have cash value, spot price, so all these functions. This is an internal function. So get debt price basically tells you what the price is of the debt. But the ending price is the vault collateral divided by the vault debt. The vault debt is that function passed by the liquidatable function, and this determines the price that you can liquidate the collateral at. And so typically they will allow you to liquidate the collateral at a discount. And so the principle there is that if the vault is liquidatable, call the liquidate function, buy the collateral at the debt price, sell it somewhere else at a profit, make money, right? Or if the collateral is USDC, then you're literally just buying dollars for less than $1, which is really good in that situation.
Right, because this is running on Arbitrum, and the transaction fees are super low.
Yeah. So there's your MEV.
Okay, so that answers my question about like having to run periodically all the time and like check. But what about how maybe are you done with the vault?
Yeah.
What about knowing when to expire the O tokens?
So that's when the vault is settled. So you can settle. So when the O token becomes expired, when the block time passes the expiry timestamp, there has to be a price settlement function. So it's actually there's a dispute period for the prices. It's like this whole thing inside of the Oracle. We have an asset pricer. That's your price Oracle, right? But we have dispute period, locking period. Locking period is like 12 hours, etc. Basically, the idea is when an option expires, you have 12 hours to dispute the settlement price, because the settlement price is used to determine what's the payoff of the option, right? That determines how much money someone can withdraw. So we have these disputers here that can be set. We can set the stable price, dispute expiry price. We have all these functions here.
But what's the mechanism that triggers the expiration of the vault?
So it's built into the vault. Remember, the vault has an expiry timestamp on it, so it's stored for. So the vault, it doesn't expire. The O tokens expire. The vault is a vault.
Right, okay.
You can have as many O tokens there as your heart desires, right? Vault stores the O tokens. That's what's going on.
It's kind of like different. It's kind of like an inversion or a different way of doing what you showed on Yahoo Finance, where instead of having that order book and all the different drop down of different expiries, now you have a vault
Right.
And
So we're going from the order book
collection
model.
of-
Mhm. We're going from the order book model to the OTC model, where if we're just trading these contracts on chain, we just have like some identifier that's the address of the vault, for example, and then you can transact that.
And so it's on me to interact with the vault after the expiry time to.
Yeah, because I mean, if you're long, if you're on the other side and you have a long position on this O token, and then the vault becomes eligible for withdrawal, meaning you can withdraw the collateral, and there's a positive payoff in your favor, then you can just redeem that excess collateral, because then suddenly the collateral requirement of the vault goes to zero. You're the owner, and then you can just call redeem, and then you get the money out.
What if I forget?
Well, then it just stays there, right? But you're the owner.
Okay. And and it's very important about the Oracle. Who is updating the Oracle?
So the Oracle we have an Oracle contract here, which kind of manages setting the pricer and setting the disputers and all these things for the O tokens, right? Of all these different methods that are defined. But like the crux is like, what do you actually use to price it? So asset pricer. Notice that's an address to address mapping, right? Or stable price, etc. So interestingly here, actually, GammaProtocol assumes a fixed price for the stable coin. So remember when USDC became under collateralized and a lot of protocols had USDC hard coded to 1? Stuff like that.
Okay.
Right? People just assume stable coins are stable.
But then you can see that they're not stable the whole
Yeah, I
time.
mean, literally there, it's an address to UN256. You're literally saying, take USDC, map it to this number. It's the integer representation of number 1. Right?
Right.
Oh, using 8 decimals. It's 1 to 8 decimals, but it's 1. Really, you should use an oracle.
And there's probably a method to change that stable price now.
Yeah, I mean, you can set stable price, right? Right here, it can be called by the owner, so we can update it. So, I mean, if you're OPYN and you're managing GammaProtocol, you can update it if the stable coin goes to 0.
But you saw that it was something above. It was a mapper of address to pricer, or it was a map of something to pricer, where pricer was an address, right?
Yeah, bro, pricer. So pricer is like an oracle. So, for example,
Asset price.
yeah, so for example, the most common oracle price sources of prices used are VWAP, TWAP, oracles. So, for example, Uniswap V2 is an extremely common way to get prices, because if you know the amount of token A and token B, you can create a TWAP oracle that just gives you the ratio of the two. You get the price using AMMs. Problem with that, though, is that these oracles can be manipulated by using flash loans or simply just depositing large amounts of money one side or the other. And there's lots of ways people have made MEV by basically manipulating oracle prices. Other possible sources of prices include private oracles, which are basically just some company comes up with a price based on different exchanges and then makes it available via reference on chain, such as Chainlink would be an example of that.
How do you manipulate an oracle price with a flash loan? How does that work?
Well, I mean, let's say I have a contract and I have an on-chain oracle that just basically tries to compute the price of ETH, let's just say ETH USDC on-chain. That's probably too liquid a pool. Let's just say Shiny Inu token or Tom Inu token or whatever shitcoin that you're trading, right? It has very small liquidity, but let's say you have a pool where one side is a shitcoin and the other side is like USDC. Well, let's say I have a loan or a vault that's collateralized by the shitcoin, right? What can I do? I can take the flash loan, I can buy up the token where the oracle is tracking it, which could be this Uniswap pool. In the trend, now that basically changes the price. I then call the method get price. Well, if that price is just computing the ratio of the quantities of the tokens in the two pools, what's going to happen is it's going to return a much higher price for the token. Cool, now I get the price for the token. What's going to happen next? Now we're going to figure, let's say, hey, I have a loan or a vault that's collateralized by this shitcoin. Well, now the price is going to be much higher. What's that going to mean? The vault's going to be over collateralized. Well, what can I do? I can now withdraw options or O tokens or collateral, or let's say it's a loan on Aave or a loan on some, arbitrary lending protocol. I can withdraw that collateral backing the position. And now that I've withdrawn the collateral backing the position, if it's sufficiently large, I can repay the loan and perhaps there's a difference. And now after the transaction completes, the price goes back to normal because the market realizes that's an unnatural condition, price crashes, and I'm left with a profit. Right? So this all happens in the same transaction, which means it requires no collateral.
Wouldn't that be cyclical? Because then after you do that, then you take out a flash loan and then sell the uncollateralized vault.
Yeah. So, I mean, basically what's happening here is you're ordering the transaction to make the thing you have it want to happen. So the way that you order transactions in the mempool is by setting the gas fees. So usually, when you use MetaMask or your favorite wallet, the gas fees are given to you based on some recommended value on what's going to go through based on demand at that time. But you could just set your own gas fees. If I set a gas fee of $1,000, I guarantee you any validator is going to want to take that. I can just look at what's the largest gas fee being offered in the mempool and say that plus one, and I can guarantee my transactions on top. Right? And so if I order the transaction so that things happen in a specific way, you can generate that type of MEV.
Okay. Thanks.
Right.
Is there code written to prevent that? Because
Preventing
bad.
MEV is an extremely hard problem. There's a lot of people proposing their own solutions for that. Flashbots, the people behind that, they certainly have their own things that they're proposing to try and address MEV. But it really depends on how you look at it. Some people would say it's a net negative to the ecosystem. Like, for example, if you're doing sandwich attacks, MEV is, of course, detrimental because it means you have a worse fill. But you could also say that, you're actually bringing markets to their Nash equilibrium, which is providing optimal utility from these assets, right? You're making markets liquid. Stopping MEV is a very hard problem. I don't think anyone has a great answer to, but there's definitely some better solutions than others.
What does MEV stand for again?
Maximal extractable value. Right. So in blockchains, it's possible to compute MEV because all the transactions, the blocks are known, versus in financial markets, MEV or traditional finance, MEV actually tends to be probabilistic because you don't know what orders are going to come in on the next period. You can't see all the order books or all the depth of these markets. So that's why blockchains are prime candidates for MEV trading versus in traditional markets, these types of arbitrages are actually probabilistic. Cool. Yeah, that's kind of all I have to say on GammaProtocol. I think I'm way over time. There's a lot going on here. I could go on forever, but yeah, are there any questions?
Asshole.
Thanks for asking. Tell the rest of us.
Teacher's pet.
Where's my apple?
Gold star for you.
Yeah, where's my gold
I
star?
left that at home, sorry. We do appreciate you asking so we can just listen.
It's a big help. Teacher's pets got made fun of in school, but we definitely didn't want to be taking any of those guys to
How can you stop that a flash loan from moving the price like that?
Isn't it like an inherent weakness in the AMM algorithm, like an order book?
So a naive approach to stop manipulating a price from a flash loan would be to use a delay. Right, that's a very naive approach where basically if I just say use the TWAP price based on the previous block. Another approach is to average across multiple protocols so that manipulating one doesn't necessarily skew it too much. There's statistical techniques you can use as well, like Windsorization when computing means, for example, so that an outlier data point doesn't skew the price that you estimate too much. So there's some methods around that. But generally speaking, if you're marking your price to a single source of truth and that source of truth can be manipulated and it's on chain, you better guarantee it will if there's a financial incentive to do so.
Crazy. Okay.
Right. be careful out there, guys.
All right.
Cool.
Cool.
Thanks for coming on, everybody.
Thanks for the presentation.
Thank you, everyone.
Yeah.